Question number 28. You see again from kinetic theory of gas, post-gravitation. You need to take care of that. 2 moles of helium gas is mixed with 3 moles of hydrogen. So one is monoatomic, other is diatomic. We need to calculate the molar specific heat of mixture at constant volume, what we commonly call as CV equivalent. All right. So here is this. CV equivalent is N1 CV1. So N1 would be 2, CV1 is 3R by 2 being monoatomic, plus N2, and N2 is 3, CV2 is 5R by 2, divided by N1 plus N2, and that is 5. This is all I require to do. Put the value of R as 8.3, even that's given, and you get option number 4 as the correct option, a straightforward one. Let's go to question number 29. Question number 29, a bit adventurous question. As you read, you would find that a person of mass m is sitting on a swing of length L and swinging with angular amplitude theta naught. The person stands up when the swing passes through its lowest point, a typical technique we generally use to speed up, right? And the work done by him, assuming that his center of mass moves by a distance of small l. So the capital L is the length of the swing, and when it reaches the mean position, the man stands up. Well, in this case, the speed would change, and if you really want to find that, you'll have to use angular momentum conservation. But the change in speed can be almost negligible given the fact the radius of the man would change, but will change by a very, very small amount. That means effectively, when you consider man as the system, the kinetic energy is almost constant. What changes is only the potential energy. And it says that the center of mass moves by a distance small l. So work done would be a straightforward mgl. So option number 1 is the correct one. Let's go to the final question, 30th. Well, the closing one, and it is related to semiconductor, and the characteristic curve of a transistor has been given. Apart from that, the input and output resistance also has been given, respectively as 100 ohm and 100 kilo ohm. We need to calculate the voltage and the power gain from this given data. You see, the base current is given in microampere, and the collector current is given in milliampere. And on the basis of this, let's try to calculate. If I say current gain, which is denoted by beta, will be IC by IB, and just try to see here. IC is 5 milliampere and IB is 100 microampere. So let's see, 5 into 10 raised to the power minus 3 divided by 100 microampere. So 100 into 10 raised to the power minus of 6. That's how it goes. Okay, so this is beta, the output current divided by the input current. And this is, say, that's a very straightforward one. The value of current gain is coming out to be 50. Once I know the current gain, I would like to calculate the voltage gain. And if I represent it by A sub V, that's current gain 50 multiplied by the resistance gain. And the resistance gain, if you see, is simply output resistance divided by the input one. And here is 100 kilo ohm divided by 100. So quite obviously, the ratio is going to be 1000. That's 10 raised to the power 3. In other words, that will be 5 into 10 raised to the power 4. That's the voltage gain. The first part has been solved. All right, if I do that, I can just eliminate the second one because that does not have the voltage gain as 5 into 10 raised to the power 4. But quite a big selection to be made among 3. And the power gain is the product of voltage gain multiplied by current gain. That's going to be 250 into 10 raised to the power 4 or 25 into 10 raised to the power 5. And as per the given option, option number 1 will be the correct option. So option number 1 comes out to be the correct option for question number 30, and together with that, we end up the session. Well, if you were the one who sat for this examination, my prayers and wishes with you so that you can excel. And if you are a future aspirant, hope the discussions were quite useful, plus the insight time to time we were giving it, though in a precise way, but wherever it was required and wherever it was contextual, the required input and the insight was shared. It's time to sign off. Thanks for watching. Thank you very much.